There is a company in Taiwan that most people have never heard of, and a huge share of the world's most advanced technology depends on it. Not in a loose 6 degrees of separation way, in a very direct way. The chip inside your phone, the one that does everything, the processor that makes it actually work, was almost certainly manufactured there. The chip powering the AI model you used last week. The chips going into the fastest laptops, the most advanced gaming hardware, the servers that run the internet's most computationally intensive work. Nearly all of it, when it comes to the cutting edge, flows through one company, in one country, on one island, that sits in one of the most geopolitically contested stretches of water on Earth. The company is called TSMC, Taiwan Semiconductor Manufacturing Company. And what makes it remarkable isn't just its size, it's what it does, and how well it does it, and how thoroughly the rest of the world has structured itself around the assumption that it will keep doing it. Here is the simplest version. TSMC makes chips for almost everyone else. Apple designs chips for the iPhone. NVIDIA designs chips for AI. AMD, Qualcomm, Broadcom, they all design chips too. But most of them don't actually build the chips themselves. They send the design to TSMC, and TSMC builds it for them. TSMC is, to put it plainly, the world's most important chip factory. And not just because it's big, because it's operating at a level of precision that almost no one else on Earth can match. The chips TSMC makes for the most advanced products, the ones powering high-end phones, AI servers, the fastest laptops, are built with features so tiny they're measured in billionths of a meter. Not because making things small is a fun engineering challenge, because smaller means faster. Smaller means more efficient. Smaller means you can pack more capability into the same space. And getting to that level of smallness took decades of compounding investment, relentless trial and error, and a manufacturing culture that treats even small defect rates as a serious problem worth obsessing over. That's the part people underestimate. This isn't like building a car factory. You can't just find a spare plot of land, order some equipment, and start producing. The tools required to build cutting-edge chips, particularly the machines that do the final, ultra-precise printing of the circuit patterns, are extraordinarily rare. The tools required to build cutting-edge chips are incredibly specialized, and the most important of them come from a very small number of suppliers. The knowledge required to run those machines well, to tune them, to coax high yields out of them, that knowledge lives inside TSMC's workforce in a way that cannot simply be packaged up and exported. TSMC has been doing this for nearly 40 years. Some of the engineers who trained under its first generation of leaders are now training a third generation. This is not something you replicate in a hurry. So let's run a thought experiment. Not a disaster, not a war, just a disruption. 7 days where TSMC's most advanced production lines go dark. Maybe it's an earthquake. Taiwan sits in a seismically active zone, and this is not a hypothetical anyone should wave away. Maybe it's a severe power disruption. Maybe it's something else entirely. The cause doesn't really matter for this exercise. What matters is the question, what actually happens next? Day 1, production stops. Nothing ships from those lines. But here's the thing. The world doesn't immediately notice. There's no alarm, no headline that says, chip emergency. Because the chips TSMC was going to make this week haven't been missed yet. They hadn't shipped yet. They were just next. The companies that were expecting deliveries start making calls. Orders get flagged. Internal projections start getting quietly revised. But this is still largely invisible to anyone outside the industry. Day 3. The factories that assemble finished products, phones, computers, servers, are still running. They have inventory. Components sitting in warehouses that were ordered weeks ago, shipped before any of this happened. The production lines keep moving. From the outside, nothing has changed. Day 5. Logistics teams start running numbers. If this continues past another week, certain component buffers start looking thin. Not empty, thin. Companies begin making quiet prioritization decisions. Which product lines are most critical? Which customers have contractual priority? Who gets the chips that do exist? Day 7. Production resumes. But here is where the real story begins. Because a chip factory isn't like a light switch. You don't just flip it back on and pick up where you left off. The manufacturing process for an advanced chip is extraordinarily long. From the moment a blank silicon wafer enters the production line to the moment a finished chip comes out the other end, you're typically looking at 2 to 3 months. Not hours, not days, months. The process involves hundreds of steps, each one building on the last, each one requiring precise conditions, temperature, cleanliness, chemical balance, that have to be carefully re-established after any interruption. So when production restarts after 7 days, the chips that were mid-process when everything stopped have to be carefully evaluated. Some of them will be fine, some won't. The first batches out of a restarted line tend to have a higher rate of defects than normal. Not because the machines are broken, but because the process has been disturbed and it takes time to get everything back into perfect rhythm. Fewer good chips coming out in those early weeks means the gap created by the shutdown doesn't close on day 8. It trails behind you for weeks, maybe longer. And the customers who are counting on a steady flow of chips now face a backlog. Not an empty shelf, a delay, a queue. In an industry where launch calendars are planned 18 months in advance, a delay of even 4 to 6 weeks can cascade into missed product announcements, delayed partnerships, revised earnings guidance. So when do you actually feel this? When does it hit ordinary life? Probably not at the grocery store. Probably not at the gas pump. The things people interact with daily, the infrastructure of normal life, runs on chips that were built months or years ago and are already installed. Those aren't going anywhere. What you'd feel if you were paying attention is more subtle. You'd notice that the new phone that was supposed to launch in November gets pushed to January. You'd see a gaming GPU go back-ordered again just when supply had finally normalized. You'd read that a car manufacturer is throttling production on its most advanced models because certain driver assistance components aren't arriving on schedule. You'd watch a tech company quietly lower its earnings forecast for the quarter, citing supply constraints, without most readers connecting that phrase to a single factory in Hsinchu. The AI infrastructure build-out would feel it too. The most advanced AI chips, the ones designed specifically for training and running large models, come overwhelmingly from TSMC's most advanced lines. A 7-day halt doesn't stop AI overnight, but it adds friction, pushes timelines, and delays the server farms that major tech companies are spending billions to build on aggressive schedules. It's one consequence among several, and not a small one. But it's downstream of the same root cause as everything else in this scenario. One company absorbing more of the world's most demanding chip work than any backup plan can currently replace. The companies that feel it first are the ones operating at the frontier of what chips can currently do. The ones building the most advanced phones, the most powerful computing hardware, the highest performance systems. These aren't niche players. Apple, Nvidia, AMD, Qualcomm, these are some of the most valuable companies in the world. Their roadmaps, their product launches, their revenue forecasts are built around a steady, predictable flow of chips from TSMC. Interrupt that flow, and the disruption moves through the supply chain like a slow wave, fast enough to be painful, slow enough that by the time the average consumer notices, the original cause is 3 months in the rearview mirror. Now, here's the question that underlies all of this. Why doesn't the world just build more of these factories somewhere else and reduce the risk? The honest answer is, it's trying to. The United States has poured enormous subsidies into attracting chip factories to American soil. TSMC is building plants in Arizona. Intel is expanding. Samsung is building in Texas. Europe has launched its own chip initiative. This is real. It's happening. But it is also genuinely slow, genuinely expensive, and genuinely complicated in ways that go beyond money. The cost of building a single state-of-the-art chip factory is somewhere in the range of $20 billion. That's before you hire and train anyone. The equipment for the most advanced production steps has wait times measured in years because the machines themselves are extraordinarily complex. One of the key printing machines, for example, is made by a Dutch company called ASML, and it took that company decades to develop the capability to build it. There's currently no real alternative supplier. So even if you have the land, the money, and the political will, you're still waiting in line for the machines. And then you have to learn to use them, really use them. Not just run them, but run them well, at the yields that make the economics actually work. TSMC achieves manufacturing quality that its competitors and would-be competitors spend years trying to match. That gap doesn't close because someone signs a contract and breaks ground. The TSMC plants being built in Arizona are real and significant. They will produce chips. But the timeline to full production is long, the initial output will be smaller than what Taiwan produces, and for the very most advanced chip designs, the ones at the absolute cutting edge, Taiwan will remain the primary source for years to come. The diversification is real. The vulnerability it's meant to address is also real, and the gap between them is measured in years. Which brings you back to the question of how this happened in the first place. And the answer is almost uncomfortable in how mundane it is. It wasn't a geopolitical scheme. It wasn't a policy failure. It happened because TSMC was simply better. For decades, it offered the best chips at the best yields at a competitive price. And the rational decision for one company after another, Apple, Nvidia, Qualcomm, AMD, dozens of others, was to use TSMC rather than try to match it. Most of these companies did not want to run their own cutting-edge chip factories. Chip factories are expensive, technically brutal, and nowhere near as profitable as designing the chips or selling the products that contain them. TSMC was extraordinary at the one thing everyone else wanted to outsource. So they outsourced it. And then they outsourced more of it. And the gap between TSMC and everyone else widened with every process generation, until walking away became genuinely unthinkable for most of the companies involved. That's the structure you're left with, a global technology economy that is extraordinarily productive, built on a manufacturing foundation that is extraordinarily concentrated, and a concentration that happened not through recklessness, but through decades of entirely reasonable individual decisions that nobody was tracking as a system. 7 days. That's all this scenario asked. And the reason 7 days matters, the reason it cascades for months rather than resolving in a week, is specifically because of what TSMC is. Not just a factory, the factory. The one that took 40 years to build, that runs processes nobody else has fully mastered, that sits at the center of a supply chain so tightly coupled that any gap in its output doesn't disappear when the machines restart. It just shifts forward in time, trailing behind the recovery like a shadow. The phone launch slips, the server farm opens late, the earnings call has a line in it about supply constraints that analysts absorb and move on from. And the factory in Taiwan, already back at full speed, keeps producing the chips the world decided it couldn't do without.